Hey guys. Alright, so I know we already took our test on systems of equations, but I'm actually going to introduce some more stuff with systems, and we might take a quiz on it, but it's going to be working with more types of word problems. These are what we're going to call distance and mixture problems though. And there's going to be a specific way of doing these. By the way, I hope you guys liked the picture. I thought that was pretty funny. Being somebody who grew up on a farm and all that kind of stuff, this really isn't true, but I thought it was pretty funny anyways. Alright, so the first thing we're going to do, we're going to look at a distance problem first, okay? And on a distance problem, let's read it first. It says a ship left the pier and traveled north at an average speed of 20 miles per hour. An aircraft carrier left sometime later, traveling in the opposite direction with an average speed of 20 miles per hour. After the container ship had traveled for 11 hours, the vessels were 440 miles apart. How long did the aircraft carrier travel? Alright, now there's going to be a couple different things we have to consider, but the biggest thing you need to remember with distance problems is you always need to remember the rule or the formula that distance equals rate times time. Now rate, I want you to look up a definition for the word rate, and I want somebody to be able to tell me what that is tomorrow, and I want it written down if you could. Alright, so we're going to use a box, okay, and this box is going to help us with some of the information that we need to do our problem. So in our problem, we're going to do distance equals rate times time. Okay? Now, on the side here, this is going to be which, in this case, which ship we're talking about. So it says a ship left the pier, so we're going to call this one a ship, and the next one we're going to call an aircraft carrier, so we're just going to label it as A. Okay? Now you're going to fill in the necessary information. So this boxes here are the distance, these ones are your rate, and these ones are your time, and you're going to have to fill those in. Alright, so it says a ship left the pier and traveled north at an average speed of 20 miles per hour. Okay, so 20 miles per hour would go here. An aircraft carrier left sometime later, traveling in the opposite direction with an average speed of 20 miles per hour. Okay, so this one is going 20 miles per hour, but it's going in the opposite direction. Okay, so let's actually draw a picture real quick. Alright, so we're going to say this is the pier. Okay, and the ship left, and we're going to call this north, and this is going to be south. This ship left and traveled this way at 20 miles per hour, and this is the S, and this one left and went this way, traveling at 20 miles per hour, and this is the aircraft carrier. Okay, we're going to keep adding to this as we go. Now, it says with an average speed of 20 miles per hour. After the container ship had traveled for 11 hours, so the container ship, so we're going to call that S still, is 11 hours, they were 440 miles apart. Okay? How long did the aircraft carrier travel? Alright, so let's look at our picture. So what it's saying is after 11 hours, these two ships, right here, we're going to say that this ship ended here, this ship ended here. Okay? So once they did that, the total distance from right here all the way to here is 440 miles. Alright? And it tells us that this ship traveled for 11 hours. So now you have to ask yourself the question. First of all, how long did the aircraft carrier travel? Do we know? No, that's what it's asking us for. So this is going to be T, because we don't know how long it traveled for. Alright? Now the distance is where it's going to be a little bit more difficult. Okay? Many kids will say, well, they traveled 440 miles. But that's not what it says. It says one traveled one direction, one traveled another direction. After the one, so after this container ship traveled 11 hours, the total distance between the two is 440 miles. Okay? So, What we need to decide then is, well, how far did the ship travel and how far did the aircraft carrier travel? Okay? So, what I know is the distance from here to here plus the distance from here to here is going to equal 440 miles. So what we're going to do is, we don't know how far the ship traveled and we don't know how far the aircraft carrier traveled. So we're going to call this D. We're going to say that the ship traveled D miles. Alright? Well, if the ship traveled D miles and they both traveled, alright, let's say I said that the ship traveled 20 miles and the aircraft carrier traveled 40 miles. How far did they travel altogether? Alright, that would be 60 miles. Now, if I said the aircraft carrier, the ship traveled 20 miles and it was 60 miles altogether in between them, then you would do 60 minus 20, which would give you 40 miles for the aircraft carrier. We're going to use that same idea here. If the ship travels D miles, and I know that D plus this distance here, so let's call this D1, we're going to call this D2. I know that D1 plus D2 equals 440, just based on the picture. So if I want to find out how far one of them traveled, then I would solve. So I'm going to say minus D2 to both sides. That means that the distance that the ship traveled equals 440 miles minus the distance that the aircraft carrier traveled. So we're going to use that information now. So this one, we're going to say is D, and this one is 440 minus D. So now we have our system. The first one is D equals 20 times 11. The second one then is 440 minus D equals 20 times T. Okay? So now we have our two equations. We're going to use these to solve. So first I'm going to figure out what this is. Okay? And 20 times 11, that means that D equals, that would be 220. Alright? Well, now I can take this and I can plug this in right here. So that means that 440 minus 220 equals 20 times T. Okay? This is going to be 220 equals 20 T. Divide by 20. And I get that T equals 11 hours. Okay, sorry about that. So that means that the aircraft carrier then traveled for 11 hours. Alright? I know the wording's a little confusing on this one just because it says it left sometime later, and this is telling us that it left at the same time. But I think there must have actually been a mistake in the wording on this problem. So the next one and the last one we're going to get to is what we call a mixture problem. And I'm actually going to draw you a box on this one as well. Okay, but this one is going to be a little bit bigger. This is going to have 3 rows and 3 columns. Okay? So it says 3 liters of 50% saline solution was mixed with 12 liters of 10% solution. Find the concentration of the new mix. Now, when I fill out one of these boxes for mixture problems, this box is going to be the amount of material. I'm going to call it amount of material. In this case, we're dealing with what is the physical amount of a solution. Okay, so the liquid. All right. This one is going to be the percentage. Now, in this case, percentage saline, which is the percentage salt. Okay, and this could change, but this is always the percentage. And then this one would be the amount of the salt. Okay, so whatever the percentage is referring to here, this is also referring to the physical amount of that. This is the physical amount of whatever we're dealing with. Now on the side here, we're going to, similar to what we did on the last one, this is 3 liters of 50% saline solution. So this is the first solution, so I'm going to call this S1. Was mixed with 12 liters of 10%. I'm going to call that solution 2. And then find the concentration of the new mixture. We're going to call this the mixture. So this is when I mix the two together. Now, let's fill in the box. So 3 liters of 50% saline solution. So the first solution, I'm using 3 liters. So this is going to be 3 liters. Now, how much percent salt? In this case, it's 50%. Now I'm going to write this as a decimal, not as a percentage. So that's 0.5. And it was mixed with, so now I don't know how much of the salt do I have. I don't know. So this is going to be X. Okay? Sorry, I do know. That's my fault. That shouldn't be X. I can figure that out because if I have 3 liters and 50% of it is salt, then I would do 3, so it's this box here times this box equals this box. So that's 3 times 0.5. Okay? And it's going to be the same all the way across. So this is going to be this times this equals times equals. Okay? So now for the second one, it says 12 liters times 10%, so that's 0.1, and that's going to be 12 times 0.1. The mixture, now, we don't know how much, for the mixture, it doesn't give us a lot of information, but there is a lot that we can figure out based on our box. So if I'm mixing 3 liters of something and 12 liters of something, I'm going to get the mixture when I mix them. So that would be 12 plus 3, which is going to be 15 liters. Okay? The percentage, this is what I don't know. This is what they're asking for, the concentration. So this is going to be X. Now this one here, okay, this is where we're going to get our problem. So I'm going to do the same thing, 15 times X. Now, for our actual problem, it is this plus this equals this. So my problem then becomes 3 times 0.5 plus 12 times 0.1 equals 15x. Okay? So now, I don't want to deal with decimals, so I'm going to start by getting rid of it. So I'm going to multiply by 10 because I only have one number after the decimals, so I can get rid of both of them by multiplying by 10. So that's 3 times 5 plus 12 times 1 equals 150 times x. Okay? So now I'm just going to simplify and I'm going to solve. So this is 15 plus 12 equals 150x. 15 and 12 is going to be 27 equals 150x. Now I'm going to divide by 27, and I'm going to get that x equals 150 divided by 27. And I made a mistake. 3 liters of 50% saline solution was mixed with 12 liters of 10% solution. Find the concentration of the new mixture. So that's 12 and 3 is 15. Okay, anyways, so 150 divided by 27, 3 times 0.5, 3 times 0.5 is going to be multiply by 10, that would be 5. This would be 12. Equals, and we have 15 liters times x is 150x. Oh, that's what I did wrong. Hold on. Let's go ahead and fix this. I actually solved the wrong way. So I would divide by 150, and I'll get 27 over 150, which means that x equals, my fault, 27 divided by 150 is going to be 0.18. And as a percentage, that means that the new concentration will have 18% saline. There we go. That makes more sense. Okay? So, I know I might have made that a little bit more confusing. Hopefully you'll write down any questions you have. But you're going to fill in this box, and just remember that it's this box times this box equals this one, and that's true all the way down. These two, you add them, and it's going to equal this one. Same here. This is the one that gives us our equation. Okay? So make sure you guys are ready to work tomorrow. I'll have some problems. I'll actually do another one of these on the board tomorrow for you to help you out. Have a great night, and we'll see you tomorrow.